Everybody, the purpose of this video is to talk a little bit about structs, about stored properties and computed properties. So let's go ahead and create a struct. Let's call it car, and let's give it two stored properties, manufacturer and weight. Now when we do this, we get an initializer for free that initializes both of its stored properties. You can think of stored properties just like instance variables. There's actually memory behind them. So if I were to say var Honda equals car, then I could provide it with a manufacturer. Honda seems right. And we'll say that the weight is 1,000. I have no idea what units those are in. Let's assume that weight is in kilograms. Okay, that's great. Now, if we did decide to create our own initializer, we could, but then this default initializer no longer becomes available to us. So for example, if we were to say init, and we just said manufacturer, then that would work, and we could say self.manufacturer is equal to manufacturer, but we would have to assign a value to weight as well. Let's assign it a value of 0.0, and this would no longer be valid. So extra argument, it isn't happy about that. We could provide a second initializer by ourselves on our own, in which we do in fact assign to both of the stored properties. So we could have manufacturer and weight, and we could say self dot and self dot. And that would be fine. And then the compiler will probably cheer up at this point. Now you may notice that these two initializers look really the same, and you might be thinking to yourself, is there some way that I could call one initializer from another? I'm glad you asked. We could in fact, from this initializer, the one that only initializes the manufacturer, to say self.init, and then we could call the second one, passing in our parameter, manufacturer, and a weight of 0.0. So this gets a little confusing because the name of the parameter here is called manufacturer, and that's also our parameter here. So we're passing in manufacturer to here, and we're passing in a weight of 0 to here. So we can create a car where we specify both manufacturer and weight, or we could create a second one where we simply provide the manufacturer. Another Honda. I don't think is really the name of a manufacturer, but we'll skip over that for now. Yes, we can use stored properties just like you can an instance variable. So for example, we could say Honda.weight is equal to 2,500, and Honda2 dot manufacturer, let's change that back to just Honda. Now let's talk about computed properties. A computed property looks like a stored property from the perspective of someone using it. You use dot notation to access and set values. However, behind the scenes, it causes some code to be executed. It isn't just assigning a value to be stored somewhere in memory. As an illustration, let's go ahead and create something here. Let's call it weight pounds. So LBS is the abbreviation for pounds. And let's provide a getter and a setter. So the getter will be, whatever code appears here will be invoked whenever we try and simply access weight pounds. And if we ever try and assign a value to weight pounds, the code in the setter will be executed. So let's simply go ahead and let's use weight. If we assume that weight is in kilograms, to convert to pounds, we'll have to multiply by 2.2. So when you ask for weight in pounds, it will return the correct value for pounds. Conversely, if we assign a value to weight in pounds, then weight would be the assigned value, which gets stored in new value divided by 2.2. We talked about this in class, the fact that there is a keyword new value that contains the assigned value. Now we might want to be a little bit more precise about this. We might want to just only allow this to happen if new value is greater than or equal to 0. So if that's the case, then we will let that assignment happen. Now, what do we do if it's negative? We don't actually handle that here. Might be a good idea to do that, but we're not going to get into error handling for a bit. So now that we have weight in pounds, I can say things like Honda dot weight pounds is equal to 1,000. So I can now work either in kilograms or I can work in pounds, as the case may be. I might actually want to change this to kilograms. That might be a better idea. We also might want to simply make this private and then create another computed property, weight in kilograms. And that might make our naming look a little bit more conventional. So in other words, we might have, let's say, weight kilogram double. And this is simply going to take weight, and so our getter can simply return weight, and our setter is going to look just like this code right here. So this is really just sort of a naming convention. So now when we can either work with weight in kilograms or weight in pounds. I'm going to need one more curly bracket to keep Xcode happy.